Now let's take more examples on integration by parts. We recall the integration by parts formula, which says integral of u dv is equals to uv minus integral of v du. And we know how to pick our u and also how to pick our dv. Applying LAET, where L stands for logarithm, A stands for arithmetic, E for exponential, and T for trigonometry. Now let's consider some examples. In our previous examples that we did in the last video, we considered using arithmetic and exponential. We considered using arithmetic and also trigonometric functions. But now let us look at how to apply logarithm functions using integration by parts. Let's take for instance that we have x, then x dx. X is arithmetic and then x is logarithm. So you pick LAET, then obviously our L comes first, which will be our u, part, and our arithmetic comes second, which should be our dv part. So in essence, we are saying u is equals to ln x and dv is equals to x dx. So if u is equals to ln x, then du dx, integrating, differentiating ln x, will give us 1 over x, and our du therefore will be equals to dx over x. Now if dv is equals to x dx, then v is integral of x with respect to x, and this will give us x squared over 2. Now let's apply our formula for integration by parts, where we have u dv is equals to uv minus integral of v du. Our u is ln x, that's integral of ln x, and our dv is x dx. Okay, now this can be rewritten as integral of x ln x dx, as the question is equals to u, which is ln x, multiplied by our v is x squared over 2, minus integral again of v as x squared over 2, and multiplied by du, and our du is dx over x. So simplifying this further, this will give us x squared over 2 ln x minus 1 over 2 as a constant integral of x dx. So this is x squared over 2 ln x minus 1 over 2, and integrating x, we will have x squared over 2 plus c. So we can factorize using x squared over 2, and this will give us ln x minus 1 over 2 plus c. And this is the final answer for x, for integral of x ln x dx. Now let's take another question of integrating ln x dx. Now we know that differentiating ln x will give us what? 1 over x, and integrating 1 over x with respect to x will give us ln x. Now how then do we now integrate ln x? Integrating ln x is determined using integration by parts, because ln x can also be written as 1 multiplied by ln x dx. So we know that 1 is arithmetic and ln x is what? Logarithm. So we apply LAET, and the first that comes up is our u, and arithmetic becomes our v. Therefore, we are saying that u is equals to ln x and the v is equals to 1 dx. And if u is equals to dx, then our du dx, if u is equals to ln x, our du dx is equals to 1 over x, and our dx will be what? And our du rather will be dx over x. And if dv is equals to 1 dx, then our v is integral of 1 dx, and integrating a constant, this will give us x. So let us apply our integration by parts formula that says integration of u dv is equals to uv minus integral of v du. We know that our u is ln x and our dv is 1 dx. So all in all, this can be written as integral of ln dx, which is the question itself. And let's follow the formula now closely. Let's apply our u is ln x, our v is x minus integral our v, which is x, and our du, which is dx over x. Now with this done, we have x ln x minus integral of 1 dx, and integrating a constant of 1, we will be left with x ln x minus x plus c. Factorizing with x, we will have ln x minus 1 plus c. Now this gives an expression for ln x with respect to x. Let's take a final example for this video. We're asked to evaluate with the integral of root x ln x with respect to the x from a lower limit of 1 to upper limit of 9. Now if we look at this, we know that this is root x, and root x can be written as x raised power half. So we can rewrite the question to be x raised power half ln x dx. Now x raised power half is arithmetic, ln x is logarithm. So if we compare with LEET, obviously we know that our ln x is equals to u and our arithmetic is equals to dv. So u will be equals to ln x and our dv is equals to what? X raised power half dx. Then du dx is 1 over x, and du will be what? Dx over x. And in this case, our v is equals to integral of x raised power half dx, and integrating x raised power half with respect to x, will have 2 over 3 x raised power 3 over 2. So with that done, let's apply our integration by parts formula, which says integral of u dv is equals to uv minus integral of v du. And with that done, we'll make our substitution. Our u dv is the question itself, which is root x dx, root x ln x dx, and our u, which is ln x, our v, which is 2 over 3 x raised power 3 over 2 minus integral of our v, which is 2 over 3 x raised power 3 over 2 multiplied by our du, and our du is what? Dx over x. So let's simplify further. And we have that the expression for integral of ln x dx is equal to 2 over 3 x raised to power 3 over 2 ln x minus 2 over 3 as a constant. And when we apply the law of indices of x raised to power 3 over 2 divided by x, we will have x raised to power half to be integrated with respect to x. So let's simplify. This will give us 2 over 3 x raised to power 3 over 2 multiplied by ln x minus 2 over 3, and integrating x raised to power half with respect to x, we will have 2 over 3 x raised to power 3 over 2 plus c. So we can factorize now, and this will give us 2 over 3 x raised to power 3 over 2 into ln x minus 2 over 3. Now we call the question as upper limit and lower limit. Upper limit of 9 and lower limit of 1 of root x ln x dx. Therefore, this will become 2 over 3 x raised to power 3 over 2, and we apply ln x minus 2 over 3, upper limit of 1, lower limit of 1, and upper limit of 9. So let's apply our upper limit first. This will give us 2 over 3 into 9 raised to power 3 over 2 multiplied by ln 9 minus 2 over 3. And let's apply our lower limit of 1, and that will give us 2 over 3 into 1 raised to power 3 over 2 multiplied by ln 1 minus 2 over 3. Now simplifying this, you give us 18 into ln 9 minus 2 over 3 minus 2 over 3 into ln 1 minus 2 over 3. And using our calculator for this, we would have to have approximately 28.0. So we have been able to consider using integration by parts for logarithm, for exponential, for arithmetic, and also for trigonometry. Now we'll take a look at how to use reduction formula, okay, for various forms. Reduction formula for various forms.